So that is the element that we've drawn. So from here, we know that stress X is equal to Px over A, right? And we know what is our Px. Px is equal to, we know that Px is equal to 240 times 10 to the power 3. And we now have to calculate the area, which is equal to pi r squared. So we have pi, and then the radius that we know is 38. So 38 divided by 2 is 19. And then squared. So if this is 0.019 squared. So it's 1.13411 times 10 to the power minus 3 meter squared. Okay. So from here, we know that stress X is equal to 240 times 10 to the power 3 divided by 1.13411 times 10 to the power minus 3. So 240 power 3 divided by 1.13411 power minus 3. It's equal to 211 positive 211.62 times 10 to the power 6 Pascal. Okay. And then we don't know our shear yet. We know the shear XY. This is equal to T, right? Tx. And we know that our C is equal to 0.019. And J, we don't know. I mean, we can find out the value. So if we have to find out the value, so J is equal to pi over 2 multiplied by 0.019 power 4, right? So if we were to substitute that in, we know that this is Tx over 0.019, okay? And then you have pi over 2 multiplied by 0.019 power 4. You can cancel this, you can cancel this, this is 3 cubed. So this will be equal to 2 divided by shift pi divided by 0.019 power 3 is equal to Tx multiplied by 92.815 times 10 to the power 3. Let me do it again. So 2 divided by shift pi divided by 0.019 power 3. Yep. Okay. So you have your shear equation. So this is what we want to find. Okay. But in order to get that, you need to determine what is your shear XY. Okay. So from here, we go back to our diagram over here. Right? We go back to our diagram over here. Let me find my green. Yeah, you'll be given. I will post on Avenue to learn the formula sheet tomorrow. Okay, I'll post it tomorrow for you guys to see. Right. So we know, right? So what we have to find now, right? There's a relationship that we know that this is equal to 125, right? And the other thing that we know is we also need to, we know that this is this distance from here to here is your 125, right? We know this has to be your 125. Okay, megapascal. We also know where is our stress average, right? We also know where is our stress average, right? So the stress average is here. Okay, this is our stress average, right? So by knowing the stress average, we also know the distance from here to here, right? So we need to find out what is the distance from here to here, right? So we know that this will be equal to stress x minus by stress y divided by 2. And then from here, then we can find our shear xy. Okay, then we can locate our shear xy. So the first thing that our strategy is we need to first locate, okay, or formulate a relationship with the maximum shear. Okay, so from here we already identify that stress mean is not equal to what? 0 from 3D mode circle. Okay, so from here we know that the first thing we know that stress mean or stress max, right? How to find stress max from here is we have to find stress average plus by tau max. Okay, we have to find stress average. So stress average is equal to stress x plus by stress y divided by 2, right? So we have to also find what is our tau max. I know tau max down here is equal to 125 times 10 to the power 6. However, what is tau max in terms of what? In terms of stress x, stress y, and in terms of shear xy. Because at the end of the day, we want to find what is our shear xy. Okay, so from here, we can immediately come up with the form that stress max or tau max is equal to, you square root the whole thing, right? Stress x minus by stress y, like what we have done yesterday. Okay. So we now know that stress max is equal to stress x plus by stress y divided by 2, and then plus by the whole thing, right? Stress x minus by stress y divided by 2 squared plus by shear xy squared. Okay. So from here, we know that stress mean, all we need to do is just make sure that we have the whole term down here, right? You put a minus sign. Okay. And then based on the criteria we know, tau max is equal to stress max minus by stress mean, right? And the whole thing divided by 2. So when that's the case, when you put this in, I'm going to put a half outside, right? So I'm going to copy this whole term, or I'm just going to paste. We have this term over here. Right? And then we minus by this term over here. And now this one has to be equal to minus. So finally, we know that tau max is equal to square root of stress x minus stress y divided by 2 squared plus by shear xy squared. Okay, we have that expression now. Okay. So now in the exam, let's say in the exam, okay, if you want to memorize, it's entirely up to you. Okay. Or if you just want to remember how to draw the circle, it's also entirely up to you. Okay. So if you know that stress mean is not equal to 0, and you can remember this, this formula will not be provided. Okay. By all means, just do it. Okay. If not, yeah, I'm sitting in on a table like in an exam will have nothing. Okay. So I just derive from first principle. Okay. Right. So from here we come up with stress max. Okay. So stress max, we know the maximum allowable is 125 times 10 to the power 6. And this whole thing will be equal to, we know that stress X is equal to, we found that 211.62 minus by 0, the whole thing divided by 2 squared plus by shear xy squared. Okay, I did not include this thing in there because I just want to calculate and determine what shear xy squared was. Okay, so from here, when I remove our shear xy will be equal to 125 times 10 to the power 6 squared minus by this term over here, 211.62 times 10 to the power 6 times 10 to the power 6 divided by 2 and then squared, and then we have to square the whole thing. Okay. So this will be equal to 125 power 6 squared minus by 211.62 power 6 divided, 125 power 6 squared minus by bracket 211.62 power 6 divided by 2 close bracket squared. Okay, and then the square root of the whole thing is equal to 66.55 times 10 to the power 6 Pascal. Okay. So this is your shear. Then from here, we just need to put in shear xy. Will then be equal to what? Will then be equal to Tx multiplied by 92.815 times 10 to the power 3. Okay. So this will be equal to Tx will be equal to 66.553 times 10 to the power 6 divide by 92.815 times 10 to the power 3. Okay. So 66.553 power 6 divided by 92.815 power 3. So it's 717.05 Newton meter. So this is the allowable, or this is the torque that you can load onto the system so it will not fail. Okay. Now another thing that we want, that I think it should be done. Okay. Or if not if, but it's good to calculate what is our stress max and what is our stress mean, okay, if the normal procedure, okay. So you have to not only check the shear. So for this case, what is going on is the shear is the